Good evening to you, and I have a question here that I want us to take ourselves through and be able to get the answers that the question demands us to give. And this question has actually been able to get extracted from a topic called angle properties of a circle. And of course, from what I have on this paper, you can realize that this is a circle and there is a figure that has been inscribed inside the circle, and that figure touches two sides of the circle and as well to these other sides of the circle, so that the circle has been touched 4 times by this figure. So this one can get called a cyclic quadrilateral. And you can also be able to get a straight line that passes through the circle. You can obviously be able to get called a chord. And from this end, you can be able to realize that if this becomes my circle, any line that passes through the center of the circle is always referred to as a diameter. And you can confirm the line passing through the center if a point O gets written down just at the center of the circle where the line is passing. And if you have a circle as well, and a line moves from the circumference, then actually ends up touching as well the circumference of the circle without passing through the center, it can get called the radius. So this can qualify to be called a diameter, and this one can become a radius for this. And we can actually have a circle, but unfortunately, we can have a line not passing through the center of the circle. When a line does not pass through the center of the circle, it gets called a chord. So a chord does not pass through the center of a circle. And at the end of the day, a chord can give us two parts of a circle. You can have what we call a minor segment and a major segment. The smaller part of that circle becomes a minor segment. Then this one becomes a major segment. A section of a whole part. So that means this can become a major segment and this can qualify to be called a minor segment. And again, I can have this as my diagram. Of course, a circle as well. Then we have the first radius reaching the center and the other radius reaching the center as well. At the end of the day, if this is the radius and this is the radius, we can give this as a sector and as well this one as well a sector. So this can become a minor sector and this can become a major sector. So two radii can meet to form a minor sector and a major sector. Correct. And this length from this point to this point can be called a minor arc of that circle, and this length to this other end can be called a major arc of the circle. Correct. So we are going to get back to the question. Angles on a straight line from our previous discussion will always tell us that they must add up to 180, and if this is 98, this other remaining angle should add up to 82 degrees. Then again, angles on a straight line add up to 180. We have 68, then we have 45. And just get the sum of those three. So we have 68 plus 45. Then you can say 180 less the answer. The remaining angle is 67 degrees. So this remaining angle is 67. So that 68 plus 45 plus 67 can add up to 180 degrees. The sum of angles in a triangle add up to 180. We have 67, we have 82. What is the remaining angle? So 67 plus 82 less 180, you can get this angle. We're going to say again, 67 plus 82, that gives us 149. So we shall have 180 less 149, that gives us 31. So that means the angle at this point is 31 degrees. Then we can actually be able to know that opposite angles in a cyclic quadrilateral must add up to 180. So this angle at this point is opposite to this angle at this point in this cyclic quadrilateral. The figure that has been inscribed inside this circle and touches the circumference of the circle at 4 points. So these are called cyclic points, or the points where the circle gets touched by this quadrilateral. So if this is 82, this opposite angle should actually be able to end up becoming equivalent to 98 degrees. I can as well use this other principle where we said one exterior angle must be equal to one opposite interior angle in a cyclic quadrilateral. So if this exterior angle is 98 degrees, that means that opposite interior angle in that cyclic quadrilateral must be equal to that exterior angle. So this must also be 98 degrees. Then you know very well, again, that one exterior angle should be equal to one opposite interior. So the whole of this part must add up to 68. Why? Because this exterior angle to the outside is 68. So the opposite interior, this angle at this point, must also add up to 68. So this is 31. You can get this. You can just say 68 less 31. You can get 37 degrees. So the angle at this point is 37 degrees. Or we can as well be able to say that still 98 plus 45, then 180 is the answer. You can get 37. Same answer can get obtained from that. So we've actually gotten each and every angle that the question is actually demanding us to give. Let's come back to the questions. The question says, from my end, you are supposed to calculate the size of angle ABD. ABD, that is 31 degrees. Then angle CBD, that is 37. So those are your answers as far as that question is concerned.